Hello. Hello, everyone. So I understand that these 30, 60, 90, 45, 45, 90-degree triangles are a little bit confusing. So here's what we're going to do. We're going to spend some time. So 45 degrees and 45 degrees and 90 degrees is what we call one of the special right triangles. So these are called special right triangles. And the reason they're called special right triangles is they have a lot of good characteristics that you can use and also remember. And when we are doing this in class, it makes more sense as we're doing these. So you have a 45, 45, 90, 30, 60, 90. These are the only two special right triangles. So let's go through a couple of examples and hopefully this will help you understand what you have to do here. So on number one, let's go ahead and see that you have a triangle like this. And I'm going to give it to you as 90 because these have to be 90 degrees. These have to be 90 degrees in order for this to work. So this only works for 90 degrees. So you might want to note that because that's very important to have under your belt. So let's go ahead and do this. And I'm just going to give you some values. So you have to give some values here. Like this is 90, right? This can be 60. And obviously, if you go 180 degrees, everything is added to 180. If I subtract 90 degrees from there, obviously you get 90 degrees. Well, then I have another angle, which is 60 degrees. So if I take that 90 degrees and go 60 degrees, obviously you're going to get 30 degrees. And this has to be 30 degrees in order for this to work. Now, going through this, you have to be very careful here. So let's try to do this as best as we can here. So if this is a 30, 60, 90, let's go ahead and say that if this was X, let's say this is the smallest side. Obviously, this has to be the smallest side because look at across. This is the smallest angle. The smallest angle of like an eyeball. You're looking at the smallest side. Let's say that was X. Okay, and then let's say that across the 60, let's go ahead and say this is going to be X square root of 3 because that's the second biggest angle. Now, take the smallest angle, and do you see how this is the largest side? Because this has the 90 degrees. This is the largest side. So you're going to take the smallest side here, and you're going to take this number, and you're going to multiply it by 2. So let's do an example of 30, 60, 90. You have this information to follow. So let's do one for you. So maybe we have something like this. And this is 60 degrees. This is 30 degrees. And let's go ahead and say, hey, what about the hypotenuse? Remember, this is called the hypotenuse. Hypotenuse is always your longest side. So I don't know, let's call it 10. Let's call it 10. What I want us to do is use 30, 60, 90, our special right triangle, and use this to get this and this. So I don't know if you want to call these something. Let's call this A, call this B. And what the heck, right? So 30 degrees, 30 degrees, remember, 30 degrees is always your smallest angle. So here's a hint, a hint. Always find the smallest side. Always find the smallest side first. Always find the smallest side first because that will help get the rest of them. So here we go. Since the hypotenuse is 90 degrees, look at this hypotenuse. This hypotenuse is 2 times this side. So think of it this way. This is 90 degrees. This is going to be that equals to that, because you know that this side already is 2 times the smallest. This side is already given to you. These two sides are already given to you. So that's going to help you find the smallest side. So what you're going to do is that you're going to take these two, which are equal, and you're going to go 2x. You're going to go 2x equals 10. You're going to put them together. You're going to put these together because you know that these are equal angles. These are equal sides. These are equal angles. These are equal angles. These are equal angles. That means these are equal sides. This is equal sides, and that's equal sides. That comes from geometry. So here we go. We're going to take these sides because they're equal. We're going to solve for x here. Now, if you solve for x, I'm hoping that you get 5. Now, I understand what you're thinking. This side and this side are the same, but look at this. Isn't this a and this is x? So just go ahead and change this to a because that's the smallest side. That's the smallest side. Remember, this side and this side are equal. So once you find that by doing some algebra here, solving, that side is going to be 5. Now, you can use the Pythagorean theorem, or guess what? Take this triangle that you should know. If you know this side, right? If this side is going to be this side, which is 5, which you found, what side can you now find with no issue? Well, if this side is the smallest, because 30 degrees, this side is the next biggest, and that's the side you want. So guess what? If this side is 5 now, what's this side going to be? Isn't these two sides equal? Correct. So what you're going to do, you're going to take whatever 5 is, and you're going to put 5 square root of 3. So you're going to put 5 square root of 3, and guess what? You found all the sides. I know that's a little tricky, but you got to know your right triangles, your 30, 60, 90, because these are special right triangles. Let's go ahead and do one without a whole lot of talking and see if you can kind of pick it up. So let's do one without any talking, because maybe talking has something important. And I'm going to change this up a little bit. So here we go. I'm going to go ahead and do this. See how I indicate 90? I'm just going to say that this is 30, this is 60. Okay? Special right triangle, right? In your head, you're going to put this as a note in your head, right? If this is 60, this is 30. Opposite is always going to be the smallest. The second largest is always going to be this. The third largest is over by 90. It's going to be 2 times this angle, which is 2x. This is your layout. This is your form. This is what you're going off of. Okay. What I'm going to do now is take this and match it with that. I understand that it looks a little different, but look at all the angles. The angles are still the same as this. So here we go. Just watch. Let's go ahead and name some of this. Why don't we call this side, I tell you what, let's call the 60-degree side. Let's do this. What about 10 square root of 3 this time? And let's go ahead and find this side and find that side. Okay, so here we go. I'm going to do this without a whole lot of talking here. So I have 60 degrees, and that is going to be equal to that. So here we go. 30 degrees. That's the smallest angle. So now I want to find this side. So I'm going to look up here, and I'm going to look right across. Ta-da, that's 20. Because this is 2x times the smallest angle. Okay, all right, so that's the first one. Hope that made sense. Okay, let's try the easy one. The other special right triangle, which is a 45, 45, 90. That's another special right triangle. Special right. And then just use triangle for short. Okay, what does this look like? Well, you're going to start with a right triangle. Looks like this. Okay, remember 45 and 45, this is 90. So 45 and 45, if you add 45 and 45, don't you get 90? And is it 90 plus 90, 180? That's all the angles in the triangle add up to 180. So you're going to go 45, 45. So let's do this. The hypotenuse is always going to be the largest side. But first, aren't these two sides the same? Because isn't this 45 and that side's 45? So let's call them x and x. Now, you could do the Pythagorean theorem. You could do a squared, b squared, and c squared, and you can find what c is. You can do that to verify, but I'm going to tell you, because make this a little faster. If this side and this side are the same, isn't this side going to be, by the Pythagorean theorem, it's going to be x squared plus x squared equals c squared, and c is going to be what? Well, it's going to be x square root of 2. You might want to check. You might want to check the work on that. Make sure that's correct. We did that already, but there you go. So let's do one of these, and I think you're all set. So here we go. I'm going to go ahead and take this away. So let's do. Here's our triangle, and this is a 45. Now I'm just going to put 45 and 90. You know darn well that this should be a 45, 45, 90 because of 180 minus 90 minus 45. So let's make a little note up here. Let's make a little note. So I'm going to make this triangle, and this is going to be 45, 45. And I know that if this is x, this side's x, this is x square root of 2. By our definition that we just figured out. So keep that in your back of your head here, why we do this one. So I'm going to say, hey, why don't we let this be 100? Let's make this be 100 feet. That's 100 feet. I want you to figure out the rest of the sides. I want you to figure out these sides. So I don't know, call this A, call this C if you really want to. So if this is a 45, 45, 90, you're going to go 45, 45, 90. You're going to use that guy up there. Well, if this side is 100 feet, isn't A going to be 100 feet also by this definition? Yeah. So A, by definition, is also 100 feet. Now, you can verify this. You can verify, if you want to, by A squared, B squared, and C squared. You can verify. But we have this to go by. So we can verify either of these. We know this. We know this. We can do it two ways. So here we go. If this is 100 feet, this is 100 feet. What do you think this is going to be? Well, I can go 100 feet squared, 100 feet squared equals c squared, right? And solve for c. Or I can go 100, 100, and guess what? You see that right there? You see how that's x square root of 2? You see how that's x, that's x? Well, I can go 100 square root of 2. Cha-ching, done. If you don't like that, solve for c there. You should get the same thing. Do I care what the square root of 2 is? No. The square root of 2 is about 1.7. I don't care. It's an irrational number. I don't care what that is. In a lot of math classes, this is fine. This is fine. So here's what I'm going to do. I'm going to do, again, another one of these without a whole lot of talking. Okay, so I'm going to go ahead and do that. So let's do one of these here without a whole lot of talking. I'm going to make it kind of change a little bit because you're always seeing it in the same view. And you can't always do that in real life. So that should be 90. Okay, so here we go. Without a hell of a lot of talking, I'm going to make this, let's see, there. That's 7 square root of 2, by the way. Remember that this is called the square root. That's called the square root. So here we go. 45, 45. So 45, 45, you got the little layout. So you might want to do this on your paper somewhere. This is x, x squared root of 2. Okay. There's my copy. If this side and this side are given, do you remember what to do? You know, set those equal. So you're going to go like this, you're going to go like this, and you're going to solve. So you have x equals 7. Do you see how I did that? I took the square root of both sides. I took the square root of both sides, and I got 7. Now, what side is 7? Well, 7 is this side and also this side. So this is 7, and this is 7. And you got it. So hopefully that worked. Let me know, and I will see what else I can do. All right? See ya.